An estimated 50 or 60% of the population will, at least once in their lifetime, be subjected to some form of severe psychological trauma. Yet it's only in around 7 or 8% it leads to significant psychiatric suffering. What are the characteristics of individuals that are unaffected? So far in this course we have mainly focused on processes that could generate disease and what makes some individuals more susceptible than others. In this video we will shift perspective and introduce you to the concept of resilience, the innate ability to withstand stress and psychiatric strain.
Resilience is a type of umbrella concept referring to resistance towards disease. Within psychiatry, resilience is relatively unexplored. There are some interesting resilience factors discovered for stress-related disorders, such as post-traumatic stress disorder, but also depression and anxiety disorders. But quite little is known about resilience in relation to psychiatric disorders that are highly heritable, such as schizophrenia, autism, or bipolar disorder, and to substance use disorders. The more you know about resilience factors, the less surprising it is who develops disease and who doesn't.
Resilience is a research field where we most likely will see much more progress in the near future. In this video we will give examples of some major components that could contribute to resilience, like hereditary factors, hormones and neurotransmitters, neural networks, environmental factors and coping strategies.
So first of all, hereditary factors. Several of the genes that protect against stress-related psychiatric conditions, such as post-traumatic stress syndrome and depression, are also involved in the regulation of the stress system and the HPA axis, such as the CRHR1 gene. Some variants of this gene might help victims of childhood abuse to not develop depression as adults. Another example is the gene encoding for the COMT enzyme that breaks down dopamine and noradrenaline. Individuals with the variant of the gene that leads to more efficient breakdown seem to be better protected against anxiety conditions and depression.
There are also hormones and signal substances that act to restore balance following stress and therefore support resilience. For example, high baseline levels of DHEA interferes with the effects of stress hormones on hippocampus. And this seems to make individuals more resistant towards extreme stress and severe psychotrauma. Another example is testosterone. It has a stabilizing effect on some critical brain regions for depression and anxiety disorders. The extended amygdala region and hippocampus. It also has an activating effect on the serotonin and dopamine systems. Together, this seems to protect against depression and anxiety.
So now let's take a look at some key principles for the brain that can maintain its functions when affected of injury or disease. Compensation, degeneracy, and the neural reserve. Compensation refers to the principle that if one node in a neural network is exposed to damage or disease, in some cases the remaining nodes of the network or other networks can compensate for the loss. So for example, following a stroke in a certain part of the brain, other parts might take over and restore the lost functions. And this can come about through an increasing activity in single nodes or an increased connection between other nodes. And this is also interesting because it shows the plasticity of the brain, that the brain has an innate ability to adapt to changing environments. It should be pointed out, however, that increased activity as a means of compensating can make neural networks more vulnerable for disease in the long run.
Degeneracy refers to a type of supercapacity backup system in our brain. Some functions can be performed by separate networks. If one of them is damaged, another can take over the drive of a previously functioning network, without having to increase its activity or having impaired function. Thirdly, neural reserve refers to an overall additional capacity in the brain, which then impacts on how large parts of the brain capacity might become damaged without leading to loss of function. We do not know a whole lot about what the neural reserve actually encompasses, but it could reflect an individual's capacity for compensation and degeneracy, or how elaborate certain networks are.
Another important factor that could promote resilience is environmental factors. So key components include the environmental status during upbringing, such as good family relations, supporting relations with other adults during upbringing, and the pro-social and supportive social network during adult years.
Finally, a few words about coping mechanisms. This partly reflects an individual's personality traits and ways of dealing with different events in life. For example, individuals with good emotional regulation are less prone to be swept away by reactions in potentially threatening situations. Such individuals can take a step back and re-evaluate the situation cognitively. They have an ability to see things from several different perspectives. Also, if they are exposed to a negative event, they are more oriented towards problem solving. In summary, individuals with good coping strategies usually feel that they can have an impact on and enjoy the situation.
So as you have noticed in this short introduction to the field of resilience in psychiatry, it is a complex system to understand, not very different from the field of psychopathology actually. An equal number of observational levels needs to be considered, both genes and environment, but also developmental aspects of the brain. So who knows, maybe we will see an RDoC-like system of the resilience soon.
The more we learn about resilience, the better we understand why some people are more prone to illness than others, and the better preventative treatment methods we can develop.